everyone, this is Vishali Pawar. Today I am here to explain the experiment number 7, that is design of a Schmitt trigger and its application for a DLIC subject. The simulation tool which I use here is the ORCAD. First I will explain the theory about this experiment, then we will simulate our circuits. So the aim of this experiment is to perform the 4 parts. First part is design an inverting Schmitt trigger. Second part is to develop an astable multivibrator based on a Schmitt trigger principle. And third and fourth part will be we are modifying the Astable multivibrator circuit to form a triangular wave generator, and the fourth part Sawtooth wave generator. So first, Schmitt trigger. When operating an op-amp in an open loop mode where a feedback is not used, for example, in a basic comparator circuit, the very large open loop gain of the op-amp will causes the smallest of the noise voltage to trigger a comparator. Here you can see that if the comparator is being used as a zero crossing detector, then such false triggering can cause a lot of problems. It may giving a wrong indication of zero crossing due to zero crossing of noise rather than the actual input signal zero crossing. Here is the noise. To avoid such unnecessary switching between high-low states at the output, a special circuit called Schmitt trigger is used with the involved a positive feedback. So in that Schmitt trigger, here is a hysteresis, means it provides a different threshold voltages for a rising and a falling edge. Here is the formula for VUTP and VLTP. The reference voltage positive Vref and negative Vref are called upper threshold. Positive is upper threshold and negative is lower threshold voltage. So next is the astable multivibrator. The op-amp multivibrator is an astable oscillator circuit that generates a rectangular output waveform using a RC time network connected to an inverting input of the operational amplifier and a voltage divider network connected to a non-inverting input. Unlike the monostable and bistable, the astable multivibrator has two states, neither of which astable is it constantly switching between the two states, with the time spent in each state controlled by the charging and discharging of the capacitor through the resistor. So here you can see the astable multivibrator circuit. The capacitor is charging and discharging. Here is the waveform for that, and the output we get the square wave. Here is the, according to the charging discharging, this will get the output at the square wave. So astable multivibrator is also called as a square wave generator because it's generating a square wave at the output. So here is the calculation for Schmitt trigger. The supply voltage is 15 volt, VUTP is 5 volt, VLTP is minus 5 volt, Vin is 10 volt. Assume that Vsat is this, and we are getting the positive Vsat is 13.5 and the negative Vsat is 13.5. So Vt is equals to R2 upon R1 plus R2 into Vsat. So we are getting the R1 is equals to 0.58 R2. Here we are assuming the R2 is 10 kilo ohm, and then according to that we get the R1 is equals to 5.87 kilo ohm theoretically, and I am choosing here the standard value is 5.6k and the 200 ohm. Here is the circuit for that. We are simulating in the ORCAD software. Go to the ORCAD software. So here I already made a circuit for an inverting Schmitt trigger. If you want to make a circuit, you go to here, place the parts and make a circuit. So here I am giving the amplitude is 10 volt and the frequency is 50 hertz. So let's run that. So here you can see the green is the input waveform and the red one is the output waveform of a inverting Schmitt trigger. So if you want to change the scale, go to here and axis setting, and here you can untick the automatic and place whichever scale you want. Then you can see here the scale. So next is, this is a wave. Here in this Schmitt trigger I taken the various frequency for the various frequency output. So for a frequency 50 hertz the waveform is this, for a 500 hertz the waveform is this, and for frequency 1 kilohertz the green one is the input and the red one is the output. You can see here the waveform of that. For a frequency 5 kilohertz the input output waveform, you can see here the output is clipped. So next is the, for a frequency 10 kilohertz the output goes into the negative. You can see here. So next is the astable multivibrator. The calculation for that is that T is equals to RC ln 1 plus beta upon 1 minus beta. Given is 1 frequency is 1 kilohertz. So where beta is equals to R2 upon R1 plus R2 and T is 1 by F, that is 1 microsecond. Beta is equals to R2 upon R1 plus R2 is equals to 0.63. So ln 1 plus beta upon 1 minus beta is equals to 1.48. So RC is this and C is equals to 0.5 micro. So R we are getting theoretically 675 ohm and standard value which I choose here is the 680 ohm. Here is the circuit for astable multivibrator. Let us simulate in the OrCAD software. So here is the astable multivibrator circuit which I already made. So here is the astable multivibrator circuit which I already made. Here is the capacitor and here is the resistor, and the calculated theoretical resistor value is 680. So let us run this. You can see here the waveform of the astable multivibrator. Green one is the input waveform and the red one is the output waveform. Green is the charging discharging waveform of the capacitor, and at the output of astable we are getting the square wave, that is the red one. So like this I get the astable multivibrator. So here you can see. So next is the astable multivibrator to RAM, that is the triangular wave generator. So here is the circuit for that triangular wave generator. Here is the Zener diode is used. The purpose of Zener diode at the output of first stage is to reduce or fix the peak to peak value of the particular value. So let us simulate this circuit in the OrCAD software. So here I already made a circuit for the triangular wave generator. Here is the stage 1 and stage 2. The output of the stage 1 is fed to as an input to the next stage. So let us run this. So here you can see the output of the triangular wave generator. Green one is the input, that is output of the first stage is fed to the as an input to the next stage. So green one is the input and red one is the triangular wave output. So next is the Sawtooth wave generator, astable multivibrator to a Sawtooth wave generator. So here is the circuit for that. The same purpose of Zener diode which I explain you use here. So let us execute this also. Go to the software. So here I already made a circuit for the Sawtooth wave generator. So V in is here, that is the first stage here, and the second stage. The output of first stage is fed to the next stage as the input. So let us run this. So you can see here the simulation window and the output is here. So green one is the input and red one is the output of the Sawtooth wave. So next is the like this, the Sawtooth wave generator. The conclusion for that is the Schmitt trigger are mainly used in a changing the sine wave to square wave. So they must be utilized in a switched rebouncer circuit for a noisy otherwise low input requirements like a cleanup or speed up. So Schmitt trigger is used in an application where the levels needs to be sensed. If only a small amount of hysteresis is used, is to reduce the multiple transition that can occur around the point of a switching. The use of a Schmitt trigger is used in a normally utilized in an application like a signal conditioning for removing signals noise digital. It is also used in a digital to analog conversion and a level detection. So astable multivibrator, I understood that the multivibrator oscillator are used in a many circuit and they are simply construct. It is possible to construct them using a couple of transistors, but it is also possible to construct a very simple multivibrator oscillator circuit using a op-amp. So the circuit can be used in a variety of application where a simple square wave oscillator circuit is required. In a view of fact, the operational is a very sharp and easy to obtain. They are often preferred of transistor because the op-amp multivibrator will use a less component, will therefore be easy to build and convenient. The astable multivibrator can be converted into a triangular and a Sawtooth wave generator by connecting the output of the op-amp to the integrator. That is, first stage is the astable multivibrator and the second stage is the integrator. There are two diodes connected between the two stages, that is the Zener diode, to reduce or fix the peak value of the particular level. So like this I performed the experiment number 7 successfully. Thank you.